So I write here host file versus DNS. It's just a bit to recap and learn a little bit more about this too, because earlier in the course we used the host file for hostname to IP resolution, but then of course we did a lot of work recently on DNS. So at this point I hope you understand the difference between these two techniques. Both techniques can be used to resolve a hostname to an IP, but the single most important difference is that DNS is centralized while the host file is not. So DNS centralized, as we have experienced recently, client just point to the DNS server and all the configuration is done on DNS server. So it's centralized on one server, and that's where you create your records and you update them. Client just need to point to that DNS server. While in the case of the host file, it is done on every machine individually. Host file must be configured on every machine locally. So that's why, in general, DNS is more interesting, because in a large network it would be tedious to go around and one by one configure and then eventually update every computer's host file. Plus, also worth mentioning, DNS provides additional configuration items. We have just seen reverse lookup, for example, different types of records, and also yesterday we have seen things like master-slave, forwarder. So DNS offers you more options as well. So at the enterprise level, for larger networks around the internet, DNS is really the option to be used. However, as network technicians, we should also know how to use the host file. It could be useful at times for troubleshooting or for temporary configuration. Now, by the way, the host file also supports IPv6. See, if I open the host file on any of my virtual machines there, we have seen yesterday with DNS how to use IPv6 records, but the host file can also be used for that. So on this machine, I'll open the host file. So I have examples actually here. So we have IPv4 host to IP resolutions. I also have an example with IPv6. All right. So again, I don't need to repeat this from scratch. We have seen this before. So the logic is simple. On the left, you put the IP, and then on the right, the host name. And it's a simple thing. The host name here will be resolved to this IP. It's very simple to use. It's just that it, compared to DNS, it has some limitations as we have just explained. So same thing for IPv6. You put the IPv6 here and a corresponding host name on the right. You also have the loopback information on top for both IPv4 and IPv6, and never edit or delete these two lines because the system needs them. You just add your own items, starting with the third line here. So that was a quick review on the host file. Any questions on it? And now I'd like to go one step further here now that we have done DNS. So both techniques are now available. You see this client machine has a host file, but it's also pointing to DNS, right? If I review my result.conf file, I am pointing to the DNS server having the IP27. So it means this machine has the two techniques available. It may look at its localhost file, and it may send a request to the DNS server to get the answer from it. You cannot prevent the host file from functioning, even when you are pointing to the DNS server. So it means, I repeat, this machine does have both options available now, which is a good thing. However, what happens in a specific scenario where you get a conflict between these two? What do I mean by conflict? See, yes, we have done recently many DNS zones there. So let's review, for example, if I do DNS lookup here, some of the records I use there, such as www.linksdrop.com or soccer.net. See, this is coming from my DNS. DNS server is saying that www.soccer.net resolves to this IP. By the way, NSLOOKUP is only with DNS. NSLOOKUP will never check the host file. The command NSLOOKUP sends the request, as you can see here, port 53, to the DNS server. So how do we check the host file then? By pinging. If you ping a name given in the host file, and if the host file does give you the answer, it'll ping the corresponding IP. So now DNS is saying that www.soccer.net resolves to the IP 251. And can I ping it? I should be able to, because the machine is online right now. So ping www.soccer.net. I can ping it, no problem. All right. And now, here's what I mean by a conflict. I will edit my host file on this machine. And I will add here a line for that same IP. And I will put here a fake IP, fake name. Actually, no, I'm doing the opposite. What I'll do here, I'll put the same name. I'll put a fake. Let me redo it. I'll put the same name as the DNS gave me, which is www.soccer.net. Let's align things to make it nicer. And now I'll put a fake IP for this. Anything, it doesn't matter. Let's say 100.100.10.1. So according to my host file on this machine, this host name should resolve to this IP. All right? According to DNS, if I do NSLOOKUP again, the same name should resolve to the IP 251. But what happens now if I ping it? If I ping this name? So what's going on here? Which of the two techniques prevails? So I just ping the name, and it's trying to ping the IP given by the host file, not the one given by DNS. And ping fails in this case because it's a fake IP I put there. If it was right IP, it would ping it, but it's a fake IP. But what you see here is that it chooses by default the IP given by the host file, not the one given by DNS. The host file is having precedence over DNS. Do you see this? See, to help you see better, just in case it's not clear, I'll go back to the host file and I'll disable this line. So it's no longer active when you put square sign. And now if I ping again, now it works. It pings the IP given by DNS because the host file is no longer contradicting it. Okay? So simple conclusion then, at least by default, the host file has priority over DNS whenever there is contradiction between the two. When there's no contradiction, no problem, both work. So any questions on this? It's an important idea, I write it here. So by default, host file has priority over DNS. Now it works the same way in Windows, by the way. I will not spend time in the lecture showing that now, but I encourage you to do it in lab time. If you go on the Windows machine and do the same thing, you'll get the same result. I'll just remind you of where the host file is in Windows. On any Windows computer, client or server, it doesn't matter. You have the host file in the following directory. You go to Windows, System32. So Windows System32, drivers, etc. So you see the path on the top, and that's where the host file is. It works exactly the same way as in Linux. You open it with Notepad, and it works, I repeat, exactly the same way, both for IPv4 and IPv6. And the same priority explanation applies here as well. If the machine points to DNS, and if there are any conflicts between the host file information and DNS information, the host file will prevail. So I encourage you to check that in the lab time, just as I did for Linux. Any questions? Yes, the host file has priority over DNS. Now, is this really important, or is it something like an insignificant detail? It is important. It has some applications. And let me give you one interesting application of this. See if I use a diagram, from yesterday. Won't be long. I renamed it as master slave. just diagram I used yesterday. So you see, pick any of the client machines. This client machine center is pointing to DNS. And one important aspect of DNS, it is in relation to websites. When you browse the internet and you type your website names in your browser, you're getting the answer from DNS. Your browser sends a request to the DNS server of your internet provider, and then that's how you get the IP of the site and you connect to it. So let's say you open your browser and connect to one of your favorite sites. But then if your local host file has a line contradicting that, you won't be able to connect to the site. In other words, let's say I open the host file again. And let's say I add a line like this. I'll put, again, a fake IP like 50 numlock. So let's say I put 50, 50, 10, 10, or something like this, 5. And then I'll put here www.google.com. So now what's going to happen if I open my browser? Let's say I put this machine online through the external switch, and I open my web browser and I tap the URL for Google. Is it going to connect? You understand my process? Here's a very practical application of it. I open the host file and I tap this line. Now let's say, try this in the lab time. Connect your, tap a line like this, then connect your machine to the external switch, go online, open Firefox, and tap the URL for Google. Would you be able to connect to it? The answer is no, you'll not be able to connect to it, because as we have seen, the host file will prevail over DNS, and therefore your browser will think that this is the IP for Google. It will fail to connect to it. Then, of course, if you put a square sign there, you should be able to connect to Google, because then you'll use the answer given by the internet provider's DNS server. So in other words, on individual computers, the host file can be used to block access to specific websites by putting fake IPs there for those sites. I repeat, on any individual computers, you may use this technique, the host file, to block access to specific websites by typing lines like this. Because, as we have seen, the host file prevails over DNS by default. Okay. Now, of course, this should be done on every computer. That's where the weakness of the host file is, right? It's not centralized. It is on every machine locally, and therefore, if it is on one machine, then only on that machine, only on this machine, my example, Google will be blocked. But if you go on a different machine in the network, you'll be able to access Google. It's not only on a per machine basis. Later we'll see in module 3, we'll see another technique to block access to specific websites, but in a centralized way. So that the whole it will apply to the whole network, but not only to specific computers there. And one more thing about this subject. It's also possible to change this default priority in Linux. We'll see this later in module 3 again. We will do some configuration in module 3 by which we will be able to give DNS higher priority than the host file. That's why I wrote by default. But I repeat, it's possible to change this, but we're not ready to see that immediately. It will be in the next module. All right, so let me know if you have any questions on a subject, comparing DNS with host file, how to use the host file, anything not clear there. So I repeat once again, I strongly encourage you to try this in a lab time. Go to first, put your machine on external switch. Initially, don't touch the host file, and just verify that once you're on the external switch, you can open Firefox and connect to Google or any site. I'm just giving Google as an example there. Then close your web browser, open the host file, and type a fake IP like this for your site. And then go back to your browser and try again to connect to the site. Okay, so if you don't have any questions, we'll move on to the main subject of today's lecture, which is routing. I'll just add here, host file can be used to block access to sites, to websites. All right, then routing. So we'll start by reviewing the definition of what routing is, and then we'll see how to set it up in our CentOS environment. So as a simple definition, routing provides connectivity between computers that are located in different IP networks. So in every semester we do some routing, right? Depending on what previous semesters you have done. We do it with Windows Server. We also do it with Cisco. Cisco actually is like the dominant company when it comes to routers and routing. And now we're doing it with Linux CentOS. It's a very important function in networking because, again, the definition is clear here. If we didn't have routers, you couldn't have any large networks, or internet wouldn't exist, because it is by using routers that you can establish communication between computers having different IP ranges, network IDs. We're not talking about the home routers, right? Those devices which are home routers have many functions which are designed for connectivity for using home computer to the internet. We're talking about the enterprise definition of routing here. Now, in the Cisco course, you also see more details. For example, we talk about the fact that routers also provide path determination. They find out the best path to reach the destination and so on. But for now, just stick to the basic definition here, which is, I repeat, providing connectivity between computers that are in different IP networks. So I'll show a simple diagram here. So I have two computers in different IP ranges here. I'm also showing IPv6 here, but for now I will stick to IPv4 to start with. If I have time today, I'll also cover IPv6, but First, we're focusing on IPv4. So you see my CentOS computer client 1, I'm assuming in the 100 range here, 192.168.100 as a network ID. Well, the Windows computer can be put in a different range, like 200, as in a 192.168.200. And so by default, they will not be able to ping each other. However, through routing, they will be able to. I will modify the diagram if necessary with the IPs, but we see the basic idea here. So the router is the go-between there to provide this translation from one network to the other, because the router will have two adapters, ETH0, ETH1. One adapter will be in one network, the second adapter in the other network. And the key for a machine to be like as a router is to have IP forwarding enabled. IP forwarding meaning forwarding packets from one adapter to the other, and therefore from one network to the other. So you take a CentOS machine, configure two adapters on it, and then enable IP forwarding. It will be a router. In fact, in Linux, it's very simple to configure, to set up a router. And then, of course, the clients will be configured in such a way that they will know where the router is, so that they will be able to use its services. So any questions on the basic idea of what the router is, what it does? I'll pause a few seconds here if you have any questions. All right, so what I'll do, first I'll put my two machines, my two clients in different IP networks, initially verify that they will not be able to ping each other, and then set up and insert the router so that it will provide connectivity. So what I'll do here, I think my Linux machine has already two adapters, so the client should have only one adapter. See, let's not mess up with things here because we also installed two adapters in our CentOS stations. But now the client needs only one adapter. The router needs two adapters. So what I'll do here, I'll check this client machine, CentOS one. As it is now, it has two adapters, ETH0, ETH1. My ETH1 is in 200. ETH0 is in 100. What I'll do for this exercise now, I will disable ETH0. I'll only use ETH1. So I'll just do IF down, ETH1. Sorry, ETH0. So IF config again. So ETH0, even with its aliases, is now disabled. My only active IP now is ETH1, which is 200.60. All right. So I'll modify my diagram a bit to avoid any confusion because I don't know what I'm doing here. So now, here is where my client 2 is CentOS. And it's 200.60. So this is the CentOS client. And my client 1 will be my Windows 10 machine. And I'll adjust the IP in a moment. So if I check my Windows machine, it is only one IP in IPv4, and that's 100.70. So before you verify any exercise like this, I mean, the first step, as I'm doing now, is to have a very neat diagram and make sure everything is correctly set up. Because often I see students who, given a lab like this, they try to do it fast, and then they don't have a clear vision of what the diagram looks like, and they end up messing up with the IPs here and there. See, it's not hard. It's just a question of being a bit disciplined here and doing things clearly step by step. Anybody can do a diagram like this, I mean. Okay, so this is my Windows machine. So as it is now, I'll try to ping between the two machines. So if I try to ping from CentOS to Windows, .70. See, I cannot because it's a different network. Likewise, if I go on the Windows machine, try to ping this one, so I'll do Control-C here to stop it. Now I'll go on the Windows machine and try in the other direction. So it's 200. What was it? 200.60. See, it tells me right away failure, because again I'm trying to ping something in a different network. So unless you have routing, this will not work. .60. All right. So it's clear so far. So the next step will be to provide a router, let the client know where the router is, and then try again pinging between the two clients. So how do we set up a CentOS server as a router? First, we need two adapters, at least two adapters. So this is the machine I'll be using as a router, this one here. And I've already set up two adapters on this. We know how to do it. We've done in the previous module. Everybody's supposed to know in this class now how to have ETH0 and ETH1 on a CentOS computer. So I have config. Here we go. I have ETH0 and ETH1. My ETH0 is 100.2, ETH1 200.2. Exactly what I'm showing on my diagram as well in IPv4. Once you have your two adapters properly set up, the only thing you need to do for this to become a router is to enable IP forwarding. And that's very simple in CentOS. It's only one file to edit, and so just very simple editing as well. So what you do on the to-be router, you go to the following path. You go to proc sysnet IPv4. And then when you do ls, there are many files here. And in particular, there is this file IP_forward. It's a text file. Let me show the path again. So this is where I am right now. If I do pwd. So we need to simply edit that file IP_forward. What's the content of this file? If I do cat IP_forward, see, in fact, by default is 0. Me, I've already changed it to 1 here. I've done it with a different class recently or whatever. But the first time you open this, or if you reboot the machine and check it, it will be 0. So 0 means disabled, 1 means enabled. It's a simple Boolean logic or on-off logic. If it's 1, it's enabled. If it's 0, it's disabled. So all you need to do is to change from 0 to 1 the contents of this file for IP forwarding to be enabled. Following? So how do we do that? There's more than one way. Of course, you may use nano. See, let's say I put it back to 0 for now, just to show the change. So I may change from 1 to 0 here, and that's it. We'll disable it. So now IP forwarding is disabled. So nano is fine. However, another interesting way of doing this, which could also be very useful at times, is the use of output redirection with the echo command. As you know, echo sends a message, right? Normally it puts it on the screen. So if let's say now I want to re-enable IP forwarding here. So see what I will do. If you type echo 1, what happens? It just writes 1 on the screen. Displays whatever follows echo as a message. It sends the output to the screen. But with output redirection, I may send this to the IP_forward file. I will overwrite the contents with this message. We have seen output redirection before. So I'll do echo 1 greater than sign IP_forward. So now it doesn't put anything on screen, but if you check the file again, now it has 1. So which of the techniques is better? Should we use nano, as I did earlier, or should we use this output redirection? The result is the same. Which one is easier? Which one would be you'd be more tempted to use on a regular basis? Nano or this echo command with output redirection? All right, one person answered echo. I agree that personally I prefer echo, but could you tell us why you prefer eco. Another person, it could be simply a personal preference, but another person might say it's easier for me to type nano than to do eco greater than sign. So it could be just a personal preference. All right, you see another person says short command. So great, but I'll give another reason why eco could be better. Because by using this eco command, you can do this through scripts. If you're running a script through which you want to enable or disable IP forwarding, and sometimes we do need to do that, then this is an excellent way of doing it. It will be hard to use nano through a script because you have to be around when nano opens, you have to type 0 or 1 in it. But this way, through a single command that you type in a script, you can enable or disable IP forwarding when you run that script, the script. So it could be part of a script. I'm not saying do a script only for this, but maybe you're doing a larger script in which, among other things, you need to enable or disable IP forwarding. So it's an excellent way with the eco command of doing it, by typing it in your script. All right, so now IP forwarding has been enabled. It means this is now ready to function as a router. My machine has 2 adapters in the proper ranges, and it says IP forwarding enabled. So it is, I repeat, a fully functional router now. So all I need to do at this point is to go on the client machines and make sure that they know where the router is. So let me start with the Windows machine. Probably you're more used to it. You've already seen how to point to a router using a Windows machine. But before that, again, I always prefer to check the basics first. You see, first I'll make sure that from this Windows machine, I can ping. Here's the Windows machine now. I'll make sure from Windows machine, I can ping the ETH0 of the router. This is sounding basic, you see. This does not depend on routing. It's basic connectivity of 2 adapters in the same range. But if I cannot ping ETH0 from Windows 10, then the rest would have no chance to work. So there is no point for me trying to use the router if I cannot even ping the ETH0 of the router from this side. So it's, don't take it for granted, because your whole thing might not work just because of a simple detail like this, you see. So let's verify that. Can I ping from Windows 10 ETH0 of the router? So ping 100.2. I can, so we're working on this side. Likewise, I'll make sure that from the CentOS client, I will be able to ping ETH1 of the router. So this should work even if IP forwarding was off. This does not depend on routing. I'm just pinging my side of the router. What IP forwarding will let me do is to ping the other network, which I cannot right now. You see, right now, if I try to ping again the Windows 7 machine, which is 100.70, I cannot do it because I don't know yet where my router is. Likewise, when I go to the Windows 10 machine, I still cannot ping the CentOS client 200.60 because I don't know where the router is. So that's my next step. I will now point to the router. And the simplest way of doing this, let's say the most common way of doing it, is through a default gateway configuration. So I'll go to the control panel, on Windows. So for default gateway, I will type the IP of the router. So which IP? I am on Windows 10 here. Which IP should I point to? ETH0 or ETH1? The answer is ETH0. On a client machine, you point to the adapter of the router which is in the same range as the client, or else it can't see in the first place, right? It has to be in the same range. So I'll point to the ETH0 IP of the router. $100.2. All right. So now on Windows 10, the Windows 10 machine knows where the router is. Can I ping at this point? Will this ping work now? Let's try. It does, however, it looks like I've already configured the R machine to point to a router. I'll show you now step by step. Now it works. Okay, I can ping CentOS client now. But I just realized that in a different course, I've already pointed to router from CentOS client. I'll go and show you how to do it. And then we'll check all the possibilities, right? Of when I can ping or I cannot ping. So now it works. So now, how do I point to router using CentOS client? Let me show that. Here's CentOS client. You go to the network configuration file. So, of course, you have to edit the file ifcfg, in this case ETH1, because I'm using ETH1, I disable ETH0. So I'll use ifcfg ETH1. And here is how you do it. It's already done here. So under the IP configuration lines, you add this line, gateway, uppercase equal, the IP of the router. And of course, in this case, it is the IP of ETH1 in the same range as this client. So this is the equivalent of the Windows control panel configuration. You open the IP configuration file of your adapter and you type under the IP lines there, under IP address and prefix, gateway equal the IP of the router. So now both clients are pointing to a router. So I'll wait a few seconds for you to take notes of the syntax here. And this is why I can ping. So from here as well, I should be able to ping now the Windows 10 machine. Okay, so it pings works now in both directions. Any question on how to configure the CentOS client? And now, what if one of them does point to a router, the other does not? In other words, let's say now I go to Windows 10 and remove it from control panel. So I'll temporarily remove the default gateway from control panel here. And now, no surprise, ping fails. When I try to ping the CentOS client, which is in the R network. But the CentOS client is still pointing to a router. So what if I go back there and try to ping Windows 10 machine? It also fails. Is it surprising? For Windows 10, it's fully understandable, right? Windows 10 is no longer pointing to a router, so it cannot ping CentOS client. But the CentOS client is still pointing to a router. I didn't remove the gateway from the IFCFG file. But I can no longer ping now the Windows 10 machine. So what's going on here? This is because ping is a two-way communication. And we'll see more details about this in module 4. But for now, I'm just giving the idea, and maybe you know it from previous courses as well with Windows. For ping to work between two machines, stop this, let's expand diagram. When one machine pings the other, there are two packets going on. First, there is an echo request packet that goes from the first machine to the second. And then the second machine has to reply with a packet called echo reply. And only when both packets are successful, only then ping will be successful. So that's why for ping to work in this scenario now, both machines, both clients need to point to the router. If one of them does not, ping will fail in both directions. It needs cooperation from both sides. So I'll restore it. I'll put it back in control panel of Windows. So now it should work again. And in the other direction too, because on CentOS I never removed it anyway. So this ping should work again now here as well. Now one more important trick to show you to make sure you understand exactly what's happening. Now, okay, so both are pinging each other. But now I'll go back to the router itself. And I will disable IP forwarding. So I'll put equals 0. And what happens now? Can the clients ping each other? It fails here. And likewise, if I go on CentOS and try to ping the same thing as before, the Windows client, it doesn't go through. Because now, even though the clients do know where the router is, they are pointing to it, now the router has been put to sleep. The router is not working now. IP forwarding has been disabled. So I'll re-enable it. And now, of course, everything should work. So I can ping again from Windows to CentOS, and likewise from CentOS to Windows. So to recap, the steps are simple. On the router, you set up your two adapters with the proper IP ranges. You enable IP forwarding, and then on the clients, you point to the appropriate default gateway IP. This was the first setup of routing, simplest. Any questions on it? Yeah, good question. It may affect, you see. So always, until further notice, don't forget to do IP tables -F. Every time you reboot a machine, CentOS machine, do IP tables -F. Don't forget about it. It's only in module 4 that will see more details on how to use the firewall. I will enable it and type rules and so on. So for the time being, to make sure that your levels will function and nothing will be blocked, always when you reboot a machine, do IP tables -F. And also, I take the opportunity, make sure SE Linux is disabled until further notice. All right, so now I'll go back to a router. So at this point, IP forwarding is enabled. It has run. Now what if on this router I need to reinitialize my adapters, like either doing a network system control restart network, or what if I do IF down, IF up? So let's say I have a reason why I need to do IF down, IF up there. So I'll do IF down, ET at 0, IF up, ET at 0. And if I check again now my IP forwarding, still 1. Okay, but what if I restart my network service? Or what if I reboot the machine? So if I do system control, restart network, which, as you know, restarts complete networking service there. And now I check again my IP forwarding. Now it's 0. This is something to be aware of. On the router, when you restart network service, or of course if you reboot the router, it will reset IP forwarding to 0. If you go with the IF down, IF up, it doesn't do that. But if you restart the network service or if you reboot the machine, it does it. But let's say I do need now to restart my network service on the router here. So it means after that, I will need to manually re-enable IP forwarding, right? Because as we have just seen here, it will reset IP forwarding to 0. Can we do a little exercise here and make it a bit more automatic? Could there be a way that I could, in one single step, restart my network service and yet keep IP forwarding enabled? I repeat my question, think about it. See, we have just seen here that when I restart, see, I'll clear the screen and do this again here. I'm just showing this part now. So we have just seen that when I restart network there within this command on the router, it resets IP forwarding to 0. It means if I do need to use this command and then afterwards I need to use routing again, I will need to re-enable IP forwarding manually. Could we automate this a little bit? Could we, in one single step, restart the network service and keep IP forwarding enabled? Any ideas, you may post it, or else I will soon give the answer. So now what's bothering me here is that I have this system control restart network. It puts my IP forwarding to 0. I don't want to experience this. I want to be able to restart my network service on a router without losing my IP forwarding. So again, the answer is something that we have to get used to as network technicians or administrators, is to have script. You can make a simple script that restarts network service and at the same time enables IP forwarding. So then you can just run the script and it takes care of it in one single step. Let me show it. So I'll go to my favorite directory to create administrative scripts for root user. So /root/bin. I create a new script. So I'll type IPF for IP forwarding or IPFOR for forwarding. And my idea is that I want to keep at the same time, I want to keep IP forwarding enabled while reinitializing my network service. You can call the script anything. So what's the basic content of this now? Is to restart network service. But now this will reset the IP forwarding to 0. But all I have to do is to follow it with the echo command to put it back to 1. Now to make the script a bit nicer, I'll start by typing a message there. So this will echo for the message. and also I'll put a sleep command for, let's say, 5 seconds. So the person running the script will see the message and will have 5 seconds to decide to stop it by pressing Control-C if you don't like what you see in the message. And also at the beginning, I'll clear the screen. Make sense? So now, as usual, I'll save this and then give enough permissions for root to execute it by doing chmod (700) for its file IP forward. So now, you see, before I run the script, what's the state of IP forwarding? It doesn't really matter. I mean, we have seen before that when you initialize the network, it disables IP forwarding. So now I will run the script. Oh, I type CLS instead of clear. CLS is the Windows command to clear the screen. Let's fix that. Unless you have an alias. Okay. So you could clear the screen and now displays a message for 5 seconds. If you want to stop it at this point, you can press Control-C, and it did the rest. It executed the commands for network reinitialization and enabling IP forwarding. So if I check now the state of the IP forwarding, let's go to proxysnet IPv4 and check IP_forward. It is 1. What if I manually put to 0 now? I'll put it to 0 manually. So it is disabled now, and I'll run the script again. Now it's back to 1. So this script does 2 things. It reinitializes the network service on its router and makes sure in the end that IP forwarding will be enabled. And by the way, you see, I just executed the script while being in this directory. You see, I'm in this directory and I'm just able to type IP forward and execute it. Why? Because I saved the file in /root/bin, which is part of the path of the root user. So I can execute it from anywhere by typing the name of the script. Any questions on this script? So let's have a look at the lecture notes there, what we covered so far. So definition of routing, basic routing, enable IP forwarding on a router, use default gateway on the client, and then use the script on a router to keep IP forwarding on when you initialize network adapters or network service. Also, when you reboot the router, of course, when you reboot the router, you'll initialize all services and IP forwarding will be off by default, but you can just run the script to put it back on. So the next thing is to talk about static routing, if you don't have any questions. So we have time before the break. It's 9:44. We have a good 15 minutes here before taking a break. So you can start doing static routing now and continue after the pause. So what do we mean by static routing? It's the same setup as before. I'm still doing the exact same setup, two clients to ping each other using a router. But now the difference is that we will not use default gateways on clients. Instead, we will type static route. Should give a bit more room here. So what's the idea here? What's the exact meaning of default gateway? When you say default gateway on a client, you're telling the client every time you need to reach a different network, please contact your gateway. So that's the only way the client has when you just use default gateway there. It means in any situation where this client needs to go outside its own network there, it will send a request to its default gateway, to the router. Static routing is more specific. When you static route instead of a default gateway, you as a network technician administrator, you'll type case by case a command static route to tell the client which router to use in order to reach a specific network. So I repeat, static route means typing a command case by case on a client machine to tell the client in order to reach such a network, please use this router. So it's not a default definition. It is really case by case. To reach network X, use this router. To reach network Y, maybe use different router. So static route is very specific. You might say, why? Isn't it simpler to use a default gateway? It is simpler. If it's simplicity what we're looking for, yes, the default gateway is simpler. But in some cases, static routing provides more accuracy or more options. So the default gateway you're pointing to might not be able to connect you to the network you're looking for. By having static routes, you keep more options open, and you may also be able to optimize your connectivity. So it's something you need to know about as network technicians. You may also type static routes on routers. Well, it's something we do in the Cisco course. Otherwise, now in this module, we're going to keep things relatively simple, only one router at a time. So we'll be using static routes on the clients. So before I show how to do it there, is the idea clear? Any questions on what static route means? So to show how to do this now, I'll go back to the square 0, meaning I will remove my default gateways. So I'll start with the CentOS client. So as it is now, I can still ping, of course, the Windows machine. But now I'll remove my default gateway from my network configuration file. I'm in the right directory, sorry. So I'll edit again my IFCFGTH1. You don't have to remove the line. You just put a square sign to disable it temporarily. But don't forget to restart the network adapter. IF down, IF up. So now it has no default gateway. And if I try to ping the Windows machine again, I cannot do it. So now I will type static route as an alternative to provide default gateway information. Are we following? Any questions? So type static route in CentOS. Let me type the syntax here. Tap route add. Sometimes I get confused between the two operating systems. If I make a mistake, I'll fix it afterwards. I think it's IP route add. Because every operating system, Linux, Windows, Cisco, have their own way to have their own syntax details for these static routes here. So IP route add. Then you specify the destination network. You see, I'm typing this now on the CentOS machine here, and the objective is to reach the 100 network. So I'll tap the net ID of the 100 network. I'll put /24 for the mask. And to specify the router, I'll tap via. So the IP of the router will be, I am here. So what used to be my default gateway, which is DTH1 of the router. Let's see if the syntax is right. Yeah, it seems to be correct. So IP route add, you put the network ID of the destination network you're trying to reach via the IP of the router that will help you. As a result of this, if I attempt the ping again now, the ping that failed a few seconds ago, now it works again. So let me know if you have any questions on this command. I'll highlight it here. don't get confused with for what sorry, what IP to type queries. It's very simple. Just think about it step by step. You are right now on this client machine, and the objective is to ping the other client in the other network. So you're here on client 2. So first idea, which IP are you trying to reach? Which network are you trying to reach? It's the 192.16800 network. That's why I typed here this. This is what I'm trying to reach. And in order to be able to, I need to contact this router. So I type via the IP of the router, which is in the same range as the client itself. All right, so there are 2 questions here. Yeah, I mean, persistent, no, I haven't shown a persistent route yet. We'll do that after a break. But it's like Windows static route. Not necessarily persistent, but it's like the Windows static route. You also do it for Windows. It's the exact same idea. Persistent, we'll do it after the break there. And I think the other question has been self-answered already. So, all right. So you see on the diagram actually which IP is 200.2. So now, how do we check this actually? When you type static route, is there we can see the result like a table? Well, here on CentOS, just type route. When you type route, it will display your routing table. And we see that the entry is here. In order to reach the 100 destination, I'm using 200.2 as a gateway. This is the result of my static route. The second line is a default line because I am in the 200 network. That's why it shows 000. Okay, but because of the static route I entered there, I got this line. Any other questions before we take a break? After the break, I will do the same thing on Windows, and then as one person already mentioned there, we will deal with persistent routes as well. Because actually, let me show that before we take a break. This is not persistent as it is, meaning if I restart network service on this client machine, or if I reboot it, this route will disappear. So let's do that right away. If I do system control here, I am on the client, right? Where I enter the static route. So if I do system control, restart network, or if I reboot the machine, and if I check my routing table again, you see, I've lost my static route. There is no gateway for it now. And if I try to ping the Windows machine again, yeah, what's happening here is that I think it put back the default gateway. Let me check, because it wasn't supposed to ping. Now default gateway is not there. Let me see what happened here, because the static route is no longer there, but somehow it got cached here. this is cached. Okay, what I'll do, just to make it clear, I'll just reboot the machine. Unless I've already configured the persistent route, I'll check it out as well now. Now let's just check this and then we'll take a break. If I'll do IP tables minus F. If I try to ping the Windows machine again, still pings it. So it looks like I already configured static route. I mean persistent route here. Let me just double check. Yeah. All right. So what we'll do now, we'll take our break, and then I'll recap the whole thing afterwards, right? I'll quickly show you again how to make a static route, and we'll also do it on Windows, and then we'll discuss persistent or not in both directions. So we'll continue this after the break. So we'll come back in 15 minutes, okay?